Okay.
So
Now,
we get,
it says the on sky angle is 202, but since you've got 3 reflections in your system, you need to take 360 minus that. And then you may have to even add 180 to it. And so I don't want to explain. My wife and I are hungry and I need to go. It's a walk to the restaurant. So I want to leave in a minute or two here, but
the 360 minus the 202.
right.
Yeah,
What's that number? It's going to be
that comes
around
out at about 160.
right. And what's the reported angle in the literature?
So the reported angle is oops, here we go.
Okay. Theta, look under theta, it's 339.
Yeah, 339, 338.
So that doesn't work either, huh?
No,
Okay, so
If you add 180 to it, it works.
yeah,
Yeah.
if you add 180 to what?
To the answer,
180. Yeah,
just
to the
got.
360 minus the 202. So if I do 360, yeah, minus 202, and then plus
plus
180,
180.
then I get
Oh, you got
That's
1800.
1800. Yeah. Still on the screen. 338. Yeah, look, really spot on. Look.
yeah. And we should go over this again in the next meeting. Let's make
This is
sure
Let's,
we
let's do
do
that, please. Yeah.
This is really,
Yeah,
yeah.
it's very important that we do this always correctly because you can totally fool yourself. But now that you know the algorithm for that telescope, it always will work.
Yeah. That's
Okay.
great. Appreciate all the help, Dave.
Yes. It's really.
All
That's
right,
phenomenal. Much
I'm gonna go because we've got to walk to the restaurant down the beach. How
Okay.
terrible, huh?
It's very terrible.
Terrible.
Dave. Yeah, I hope you have a better day, Dave, than what's been.
All right, guys, thanks so much. It was a
Thank you.
pleasure. to
Yeah,
see you.
this is
All right.
great.
Okay.
Well,
try to
I'll
join-
let you guys all know what comes out of obviously this session, right? The automated one, and definitely able to do some corrections based on that advice, David. And then definitely next week, let's go through just getting that position angle calculation correct. Yeah.
Right, and
Super.
I'll show you how it's justified. Okay.
All right.
All
Okay.
right. Take care, guys. Bye-bye.
All right.
Take care.
Thank
man.
you.
I have a question about where do we upload target lists for the Barrow telescope? Where and how?
We we haven't set it up yet because we've been still fighting
Oh.
these sorts of problems. But for right now, you can just email it to me and
Okay.
that'll work fine
Okay.
until I get a good system set up. It's a.
And I was
hot
just-
topic.
I have a quick question. Noticing with the STB, the target is the target, which is of the two stars is the target? I guess I'm a little confused. I thought it was the brighter.
So it's usually, I mean, it's always, I mean, the brighter one obviously is usually obvious. The secondary, the primary one is usually the brightest, right? And
Yeah, the
Right, but
primary-
I thought you
Primary
split
is the
them there.
brightest, and that's what Dave calls the reference. It's the
Yeah.
primary, the brightest star, whatever it is.
Okay.
And then the target is the fainter one.
Right, but I just, maybe I was miswatching, but I thought you flipped them there, but I guess not.
No. And the way this part of the app works, it will always give you the background first, then it gives you the reference one, which is really for the secondary, the green colored one.
No,
And then
that's
the-
not,
No, it's no,
that's
the
not
reference
true.
is
It's the
primary.
opposite.
Yeah, that's what I thought. I thought you
Yeah.
flipped them there.
The reference is the brightest star, Mark.
Okay. Okay.
That's why you had to add a
Oh,
180.
okay. All right.
Is
Well,
that where the
let me
180?
rerun this again. Well, let me
that's
rerun
where the
this
180
again.
came from, perhaps?
Yeah.
That's probably
Yeah.
where the 180 came from.
Yeah, that's what happened. Yep.
All right, so there we go. Let me do the background one there. There we go. All right, so then I'm going to do it on do the reference star, and I want to make the aperture larger. It sometimes doesn't let you take it larger for some reason.
You have to set it in the measurement tool.
Where's that?
In the measurement tool itself,
Yes.
how do you do that?
You see the upper left of your screen there where it's got the measurement tool? You just
Yeah,
say instead of 8 pixels, say 10 pixels. It'll make it bigger.
oh, okay. So if I did 12, where's it gone again?
Then you'll see that the size has grown.
Yeah, I mean, it's definitely got larger. Yeah, actually, that's not a bad fit.
If you zoom in a little closer when things are small, it makes it easier to.
Yeah,
what's going
well, I
on.
wasn't going to do it like perfect now that I'd normally do. I normally zoom in and spend some time on it. Now, where's my screen gone again?
One thing to be careful of is on the measurement tool. If you're interested in the photometry results, then you have to make those two apertures the same size for the
Oh, for photometry.
reference and the target, because otherwise you're getting a different percentage of the light
Right.
for each star. So you got a 12 and a 20. That's a mismatch.
Yeah.
Okay,
That's for
so we
It's
need
not-
to make
it's not-
this.
The results
Yeah.
aren't too bad for astrometry, but they're disastrous for photometry.
Gotcha. Yeah.
I like to make the background a bigger size, just so I don't get stuck on one.
Yeah, I normally do.
Five
And again,
pixel or
I'm
something.
wondering why I couldn't. Let me start over again. Yeah, I normally do make that larger, and that's why I couldn't understand. I'd obviously forgotten how to do this part. I mean, even like 40 pixels, right?
Yeah,
Get a nice size. That certainly should help the background piece. And then now if I do the reference star 12, that's, pretty good fit, I think there. So I'll set that one. Now this is not great, obviously, because it's got a boundary around it. So I might actually want to make this, maybe make them both, I don't know, 10. Would that be better so that it,
yeah, because it looks like the secondary star is kind of sitting there on the first airy ring, maybe. So
yeah,
it's got some background
it has got
competing with it.
some background noise.
So keeping it on the small side is probably a better idea.
Okay.
I think I've lost connection.
I don't know if
There we
that's an airy ring or if that's some junk. Residual clouds.
Yeah, boy. It's amazing. This night had cirrus blowing by, so there's going to be inconsistencies.
Here we go. So I lost you guys for a moment.
Yeah.
So I'll put the background there for the moment, and then you want to change that. I had that back down to maybe 8. Make them both 8 then.
What I like to do is zoom in on the image.
Yeah.
With the pluses, and then wiggle the aperture a little bit and see if the X stays solid.
Mm-hmm.
Okay. So if I go back and not so worried about the background, I probably
No,
want to
not the
make it
background.
even bigger. So now I'm on this one here. So you're saying, yeah, so like I sense at the moment, the X is staying nicely in the middle. But I
Well,
don't want to make it
It's drifting a little bit as you move. It
right.
should- So it might help to enlarge the aperture just a little bit,
Okay.
maybe one more pixel or two.
Okay.
Sometimes it's pretty sensitive where it finds the centroid to how big the aperture is.
Okay.
But
Yeah,
the
there
trick
is less,
to,
there's less movement on it now than there was
Yeah.
today.
the trick is to find an aperture that where they're both, both stars are pretty solid.
Right.
So it's found a good centroid for both of them. That's
Now that
trickier.
one's a lot better, isn't it?
But if you're only doing astrometry, you can have separate apertures, sizes.
Yeah.
Okay.
Because the aperture just determines
Yeah.
where the centroid is going to be. And if it's an odd shape like these are, which they almost
Yeah.
always are, then it's going to depend on the size of the aperture. But
Yeah, I mean, this one's very
Yeah,
challenging. It's elongated as well.
right, the faint ones are always going to be difficult.
Yeah, this is, like we said, it's a 3 delta.
Yeah,
magnitude
almost
of
4
3.
magnitude difference. I mean,
Yeah, I'll bet, Pat, I'll bet you that the problem wasn't your collimation. I'll bet it was clouds.
It could have been clouds. And it also, I was running 20 milliseconds, but I didn't know with a 5 magnitude primary. I mean, this just tells me, I didn't know as a guess at 20 milliseconds. So
Yeah, well, if the bright one doesn't saturate, then you can go longer and still get away with it. At
okay.
least 30, maybe even 40.
Do you think?
Oh,
I-
with an eye filter, you're in an eye filter. Oh, yeah,
Eye
you could go to 60, I'll bet.
Well, I works really well for ours. I don't know why, but that
Well, the seeing's better in eye, that's why.
yeah, no, exactly.
It's slower.
Yeah, but did that look saturated?
I-
Didn't, so it could have been longer?
Like Dave says, you need to look at the original images to see if it's
Yeah.
Yeah.
saturated, probably. I don't think it's saturated.
Okay,
okay.
so what was
Your
your
result-
So,
there.
so back to here now, we're getting,
The results
already.
are right on. That 21 degree, 360 minus 21 is right at
yeah,
339.
right at 340, yeah. So we're right at that point,
Okay,
and we've
Yeah,
got
without-
1.566. I mean,
Without the 180, right?
yeah, without the 180. Yeah. All right. Well, hey, I've learned a lot this morning, I tell you.
I'm gonna have to run as well here. I
Yeah.
have a couple things to do. But Pat, I think be sending you a target list
good, okay,
and then the link to where the data is there. If there's a standard Dropbox link rather than emailing a new link every time.
I'll just set one up that's standard and she'll get your data then. Okay,
Yeah.
Great,
okay,
excellent. Okay,
Yeah.
I have to run. Thanks, everyone.
okay, Paul,
Thanks, everyone.
Yeah, I have to go as well.
Yeah.
yeah,
But
I understand.
I'll let you know when I hear something from George, if I hear anything about the focus.
Yeah, that'd be great. And
Yeah.
and just so we've got another run that that I'm trying to do when the clouds clear, which will be the same targets, both north for Chile and Barrow, which will be an interesting outcome.
Yeah.
Yeah.
Was that the list that you sent for the telescopes in Chile?
The targets I put in there.
Yeah.
Yeah.
So those targets are the same that you're gonna do
Yeah.
on Barrow? Okay.
Yeah. That'll be very cool. That'll be very
Yeah.
interesting to see the comparison. And it's for all 3 scopes. Okay.
Great.
This was pretty productive. Unfortunately, for some reason, my Zoom kept coming in and out. I don't know why. It's brand-
Yeah, I know. We'd lost you a few
And
times.
so the recording is
Yeah.
going to be terrible. And Mark, I think maybe I'd like to get on with you with Zoom and walk
Definitely.
through what the final analysis, the final procedure.
Yeah,
And record it so we can all go back to it.
exactly. Yeah, when Dave started talking the important parts, she came back on again, I heard. So there should be some Yeah, and I've been making notes anyway on the practical advice from Dave and Rick. Thank you, Rick, as well.
Yeah.
Much
So now, Rick,
appreciated.
have you been doing,
I have to run. Bye-bye.
Bye-bye, Nick.
Yes.
Rick, have you been using the automated tool?
No,
No.
no, I've done everything manually.
Oh, wow.
Brute force and ignorance, that's my method.
Yeah.
Oh,
Well, you definitely helped a lot today, Rick. And so I'm going to go through and make the corrections based on what you guys told me, especially the angle calculation. So that will, I think, solve a number of inconsistencies. And just on, yeah, the technicalities of aligning the, the apertures up and all of that. So that's very helpful. Thank you.
Dave
So-
worked out that 360 business at Mount Wilson because we had the same issue there with 3 reflections.
mhm.
Right.
And so it
That's
seems
what-
to be a pretty solid solution.
So what,
That'll be a parameter for it.
my Zoom was going in and out. What's the final adjustment that say, how did it
So
finally
it's,
work out?
so it's basically 360
360?
degrees. Yeah. Minus the measurement that we get, the 202.39
The on-sky
on
measurement
sky measurement.
angle. Yeah.
And that 360 minus, how much, 86 was it?
So on this one here, it's 360 minus 21.28.
Oh,
21.
20, okay, I didn't see what it was. Okay,
Yeah.
all right, and that gets, okay, that makes sense, okay.
Yeah.
Rick, do you think it would make sense to have Dave put a parameter in there for how many reflections, how many optical services you got? And it'd be easy enough to do
That
that.
might be it.
Yeah,
Yeah. that might be
Or
right.
not.
I've asked him about that long ago and he didn't want to do anything with it.
Well, let's ask him again because there's enough confusion.
But he
No.
may agree to it now.
Yeah.
You
But
might,
it's just-
'cause this
He
goes to
he
other
just doesn't
people.
like to get into the code and try to make changes because he has to remember every little detail in order to not.
Yeah, I
screw it
know.
up.
Oh,
So he's really
Always
averse to going back in and screwing around with STB.
Yeah,
yeah.
I understood. Well, this having it automated is just a tremendous step. forward.
Oh, huge. Yeah. I mean,
I mean,
yeah, I
it's
could have saved myself a lot of hours this week. So, but you know what? It's good to refresh yourself though on the process. So, it's
Yeah.
never a
So
bad
Pat,
thing.
this is Chandru. I was wondering if the automated version, are you going to be able to post it for the Mount Wilson?
Mount Wilson wasn't shot that way. unfortunately.
Yeah. Oh, it wasn't shot that way. That's right. That's right.
Yeah.
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 So we'll
unfortunately.
have to do the manual process for that
Have to
one.
do the manual process,
Yeah.
but anybody that wants to join us now going forward, like I was saying at Mount Wilson, that wants to do, join a team to do some serious astronomy, we're gonna be doing it this way.
Oh, that's great. That's great.
Yes, and so you don't, we'll not be doing it manually.
Mhm.
Because we want to be able to go through dozens of stars a night. if possible.
Right. Exactly. Yeah. And get the results the same day instead
Yeah.
of doing the,
Yeah.
Yeah, it completely changes it, and particularly for a high school student. This is, they're not patient enough, I don't think, to go through all. of it.
Well, yeah, for them, it just becomes push this button, push that button, and they really don't know why you're doing any of these things. So, yeah.
But you still
But
always
then
have
this-
to do this manual
have to do
procedure
the-
of making
yeah.
the measurement.
Oh, yeah.
That
And
ends
this
up
is
to be
the
the most
this is
time
the
consuming part,
fascinating part. Exactly, it is the most time consuming part, and it's
but it's also the
actually
most fun.
exactly the most fun anyway. It's,
Yeah.
Yeah.
This is far more fun than watching your computer spin. So, okay. Tom, I see you shaking your head.
No. I'm just thinking I got to scoot out of here myself. I hate to leave you guys, but
Yeah.
I got to pick up with you eventually and start doing it again. So,
Hey,
Okay.
Tom, can I ask you one thing real quick?
yeah.
I'm finishing up the data, the speckle photometry data that I took at the Orange County telescope last year, trying to get it wrapped up and get a paper out. And I've got it almost done and all the data reduction's done, but I have some questions about the APAS 10 Sloan data that
Okay,
I used as kind of a reference for making the photometric transformations. And
yeah,
I'd like to run that paper by you and see what you think. If you got time to
yeah,
read it.
absolutely. Send it on, Rick. I'll be happy to look at it.
Okay, I'll try and get it out of here in the next couple of days.
Good deal, no problem.
Okay, thanks.
Right.
See
Okay,
y'all.
see you.
Okay, bye-bye.
I think I've done what I wanted to do today, which this is a very productive session.
Yeah, it's been a good session.
Yeah. So unfortunately, the recording is just going to be completely messed up. I don't know how it's going to work. But the last part will be okay, which is Rick's magic on how to do it, measure it properly.
Yeah.
Anything else from anybody else? Okay, well, we'll wrap it up. And Mark, I'd like to get together with you and we'll maybe, if nothing else, we'll substitute the video of when you and I work together on doing it correctly. Okay,
Correct. Exactly.
All right.
Exactly. All right.
excellent.
Yeah. Just let me know.
All right, bye.
All right. Thanks. Bye.
Bye.
Bye-bye.